In this video, we're going to show you how to use a new PowerNavigator GUI to set up an offline project. What we mean by offline project is the ability to have an entire system architected and crafted without any hardware attached. This is a great way to come in and initially design your system. You can play around with different input, output voltages. You can try and drop in different products and see what fits best for your architecture. Once you've got it optimized, you can then go into the entire design procedure and set up the individual parameters. That way, when your hardware finally comes back, you're ready to go. You don't have any delay time in setting up and configuring the products. So let's show you how this works. We can do this by launching PowerNavigator. When the launch screen comes up, you'll see you have three different choices. You can scan devices, build an offline system, or launch from a project. Since we're going to start a brand new project, we're going to click on the Build Offline System and push Start. Now what we mean by offline is offline in the sense of no hardware is attached. So this can be run completely on your laptop without any connection to the website or any connection to a power board. You can set up your entire power rails, get the sequencing to work, get all the fault protection set up, and then save the project. That way you're ready to go when your hardware first arrives. The first screen that you see that pops up is the part library. And this is the place where you can sit there and control and drag in any products you'd want to use. Now all these screens are configurable, so at the bottom you can see a message viewer and the memory tools. We don't need these right now, so we'll just hide these out of the way. So let's go ahead and set up a system. You can see we've got a standard source that's coming in, and maybe for identification purposes, we want to name this a 12-volt input. For this design, we're going to use the ZO8800, which is either a dual phase or a dual output product. So if I grab this device and drag it into the system, you'll see it will drop in and it says default of 3.3 volt output. Now this is automatically configured as a two-phase because you can see these two green dots. As I scroll over them, they turn yellow. These represent the two different phases. Another way you can see this is by clicking on this tab on the top right. Right now it's the power view, but if I switch it to the phase list, you can see that calls out there's an 8800 phase 0 and the phase 1 configured on that output rail. Let's go ahead and make this a single output version only. So we're going to take one of these dots and drag it down onto this node, and now we've got two different outputs set up, and maybe I want them to have different voltages. Top one at 2.5 volts, and the second one at 1.8. We can also add in any other devices, such as the 9006 module. I can drop in and put on a node here. Or if you want to cascade it, maybe you want a 12 volt to 5 volt converter and then go from 5 to 3.3. I can sit there and do that by grabbing this and dropping it anywhere else on the schematic. So let's set this up for 12 to 5 and now 5 to 3.3. So this completes a power tree, which gives you a quick glance at how your system is going to be architected. Now to go in and set up each individual projects, we can go in and use the monitoring view, the sequencing, or the command tools. So let's go ahead and go into the monitoring view and set up the devices. So clicking on that tab, you can see it comes up and it says rail number 1. And that's because that's the one that's highlighted. You can see that blue box that rings rail number 1. If we click on any other rail at the bottom, we can change which one's monitored, rail 0, rail 1, or rail 2. If you want to have them all displayed, all you need to do is hold the control key down and click on all the different rails. Now, the first place to start here is rail 0, rail 1, rail 2. It's not the most descriptive term. And it's easy with multiple rails to get confused on which one's your memory, which one's your CPU core, which one's the FPGA. So we could just easily go in and name them. Just going into the power view, we can double click, and where it says rail 0, maybe this is the CPU. Rail 1, double click on this, maybe this is an I/O. And then rail 2, we can name this anything else. Maybe it's a memory rail. But whatever you need, you can just type it in. So now we have all the rails appropriately labeled. We can go through and we can configure the device. So what you see on the monitoring view is the ability to go in and click on any of these parameters. output voltage, output current, or even the input current. If you click on that little dialog box on the bottom right of each one, it will launch up the different parameters around that command. So in this box, you can see we have all the parameters related to the output voltage that can be easily adjusted at our fingertips. This selects two things, the parameters of the device and also how you want to see the readout on the GUI. So for instance, at the bottom, you can see the output voltage is 5 volts. Well, maybe we want to increase this to 5.5 volts. And you can see how it updates it on the screen, on the monitoring view, and also on the power map view. So everything is linked. You have multiple places you can change it. Back to this dialog, you can see output voltage fault limits, under voltage fault limits, everything can be adjusted. And you have the option of putting in terms of percentages or in absolute voltage, all by selecting the checkbox below, toggling between how you want to be a voltage or a percentage. And you can toggle the checkbox below, so if you want to enter a fault limit in terms of a percentage or as an absolute voltage, is your choice, whatever makes it easiest for setting up the device. The same can be applied with the output current. Clicking on that little box on the bottom right, you can see you can set up the overcurrent fault limits, the undercurrent fault limits, and also how the device is displayed. When you finish designing your entire power system, the next step to do is to save this project. That way you can access it at any time in the future. In order to do this, just go to the File menu at the very top and click Save. By saving it as a project file, what it does is it saves all the settings behind this, all the devices, how it's configured, how the device is sequenced. That way you can design and tweak the entire system offline without hardware and have it perfectly ready for when your boards come back from PCB house. Now behind all these products, there's a lot more parameters that can be individually tuned and adjusted. Now these aren't all displayed just from a complexity, but if you'd like to go in and tune each one of these, there is a mode called the command line tool. And in the next video, I'll show you how to use this.